Alright, so in this video we go over section 6.2, integration by substitution. Okay, so when do we do substitution? So let's consider these two integrals right here. They look similar, as you can tell. However, their difference right here is the exponent. One has an exponent 2 on the integrand. The other one has an exponent 9 in the integrand. Alright, if we were to evaluate this integral without knowing substitution, well, it wouldn't be that bad to evaluate it, because we can expand the binomial using the binomial formula. 9x squared, 3 times 4, that's 12, times 2, that's 24x plus 16. And then integrate term by term. So we get 9x cubed over 3 plus 24x squared over 2 plus 16x plus c. And simplifying these guys, we get 3x cubed plus 12x squared plus 16x plus c. Okay, that'll be it for this example. Now, notice in this case, what did I do? I FOIL 3x plus 4 times itself. So we did foiling. For twice it's not that bad. Even for cubed, it's still alright. However, when it comes to something like this, so 3x plus 4 times 3x plus 4 dot dot dot, this done 9 times. I don't think it's a good idea to do it 9 times, right? So the moment you do it at most, I'm gonna say most, 3 times, it's already annoying. All right. So now imagine doing this foiling 9 times. And that's not practical. It is doable, I mean, if you have the time and most importantly the patience, but no, it's not the best choice. All right, so how are we going to do this? Using substitution. I'm going to go over this example later in this video. In the meantime, I'm going to go over a couple of pretty much straightforward examples in which we do substitution. Well, so we need to determine a u and a du, just for the trick of the trade. Let me see. So u, it's always going to be expression inside parentheses or radical or the exponent, or rather the expression as the exponent of an exponential function. All right, so that's how we check for our u. Okay, this is very important. Let me put it inside this little box. All right, let's look at an example. So we want to evaluate this integral, the integral of x squared minus 12 to the 4th power times 2x. So if we didn't know how to do integration by substitution, you will have to FOIL this guy 4 times. Again, that's not the best and most efficient way to do this, and then multiply everything by 2x. All right, so in this case, there's something we need to recognize. Notice the quantity inside of the parentheses is 1 degree higher than the quantity that is outside of the parentheses. So that is in a way a pattern that we need to recognize, as you will see throughout these examples. So in this case, u equals x squared minus 12. We need to find du dx, which is 2x, and then solve for du. 2x dx. So basically we are taking the differential as we learned last semester in first calculus semester. So there's two pieces of information that we need to take care. Number one, the u, and number two, the du. Okay, so in this case, notice how the 2x dx matches exactly our du. And in this case, notice, well, our u is the quantity, again, inside of the parentheses. So this is going to be, okay, I'm going to put the equal sign here because I'm running out of space here. So I'm going to have the integral of u to the 4th power times du. And all we do is use the rules that we learned in the previous video. So this is u to the 5th over 5 plus c. So we are done essentially with the integration. Now we need to go back and substitute for what u is. In this case, x squared minus 12 to the 5th power divided by 5. And no need to expand a binomial to the 4th power and then do painful calculation, painful algebraic manipulations, which again, it is doable, but it's not the most efficient way. Alright, let's look at the second example. The second example, notice we have an algebraic expression as the exponent of an exponential function. And look at the quantity multiplying the dx. Look at the degree is one less higher than our expression at the top of the e to the x, of the exponential function rather. So in this case, we are going to set our u to be our x cubed. Let's take the differential du 3x squared times dx. And notice again in this case, this 3x squared dx is exactly the same as this one right there. So in this case, we can just go ahead and perform the substitution. So e to the u du. And again, the integral of e to the u is simply itself e to the u plus c. And we are essentially done with the calculus. All we do is back substitute e to the x cubed plus c. Of course, you can do calculus and verify this result. So let me do it on the side using a different color here. So what am I going to do? Okay, I'm going to take the derivative of this. Take the derivative. So it's going to be 5 times x squared minus 12 to the 5 minus 1, which is 4, divided by 5. The derivative of a constant is 0. Cancel these 5s. What do we get? X squared minus 12 to the 4th power. Isn't that the... Oh, I forgot times 2x because there's a chain rule. And notice it matches our integrand right here. Same thing here. Take the derivative. The derivative of an exponential is itself times the derivative of whatever do we have on the exponent, which is the derivative of x cubed, which is 3x squared. And the derivative of the constant is 0. And again, notice how it matches the integrand. So we did the integration correctly. Okay, let's turn the page and look at more examples. Okay, so we have another very straightforward example here in which, in this case, well, we need to be careful when identifying this pattern, parenthesis, in the quantity inside of the parentheses, because in this case there's no parentheses. However, if you will, these parentheses, you can put them in there and it's raised to the first power. Why do we do that? Because also look at the exponent, x to the 6, look at the degree, x to the 6, this is 1 degree less. So that should work as our u du. So u equals x to the 6 plus 4. The differential of this expression is going to be 6x to the 5th dx, which is exactly what we have at the top. So in this case, this that I'm grouping here matches our du, so that becomes a du. So we get the integral of du over u, and well, in this case we have essentially 1 over u. The integral of 1 over u is ln of absolute value of u plus c. We are essentially done with the calculus again. All we do is back substitute. Ln of x to the 6th power plus 4 plus c. Final answer. Okay. Now, throughout these examples A through C, well, everything has worked very, very nicely in terms of u du. However, in some cases, in most of the cases, we are going to get examples in which we need to make some adjustments, which is multiplying by inside and outside by constants in order to have our u and the du to match. So and because ultimately this is what we want to obtain as something that looks like u to the n, e to the u, du over u, as we did earlier in these few examples. Okay, now let's do the example I proposed earlier, in which you don't want to do this foiling 9 times. So let's see. So u equals 3x plus 4. The differential of this will be 3 dx. Alright, I'm going to rewrite the integral here. So, because I need to leave some space. The integral of 3x plus 4 to the 9th. And I'm going to leave some space here in between. If we try and compare, right, if we try and compare our expressions, notice that in order to replace this quantity with a du, there's something missing. There is a 3 missing. So we are going to add what we call a correction factor, right? This correction factor, if I multiply, in this case by 3, because we wished we had a 3, so we can make our wish come true. Yes, multiply by 3 provided you do the opposite of multiplying by 3, which is dividing by 3. That way, you are multiplying by 3, dividing by 3. Essentially, you are multiplying by 1, which does not affect the value of the expression that we are working on. So now that we are ready to do the substitution, let's see, this is going to be 1/3 times the integral of u to the 9th times du, because again, this is going to be our du, right? So the integral of u to the 9 will be u to the 10 divided by 10, but don't forget this 1/3 in the front plus c. We are essentially done with the calculus. Let's simplify this. On the one hand, 1 times u to the 10, well, let me do the denominator. 3 times 10 in the denominator, that's at 30. And you might want to replace with what you said as a u, which in this case is 3x plus 4 to the 10th power plus c. Take the derivative of this, and you should get this same quantity right here. All right. It would take a mini chain rule here. All right, let's do another example. So an exponential function times x cubed. So e to the x to the 4 times x cubed. So again, the pattern here is to set u as the highest degree. All right, so u x to the 4th the differential will be 4x cubed dx. Alright? So, if we compare the integrand with our setup here, notice there's something missing. Here we wished we had a 4. Yes, I can make it happen. We can make our wishes come true, provided divide 1 out. Okay? Add a correction factor. So this is now going to work as our du. And we are ready to perform the substitution. 1/4 times the integral of e to the u du. And the integral of e to the u is simply e to the u plus c. Don't forget this factor of 1/4 that we added at the beginning. Now we need to do the back substitution for u. That is going to be 1/4 e to the x to the 4th plus c. Let's do one last example illustrating the integration by substitution. So again, look at the exponent of the denominator, which is 1 degree higher than the degree of the numerator. So in this case, it's going to work to set u 2x cubed plus 1. The differential of this in this case is going to be 6x squared dx. Alright, and if you observe the integral very closely, we have x squared dx, x squared dx. What is missing in this case? That is correct, the number 6. We wish we had a 6, so it worked provided we divide 1 out. Alright, so let's do the substitution. In this case, this is going to be our du, right? Just the same as we group it here. That's going to be our du 6x squared dx. That's our du. So this will be 1/6 times the integral of du over u. The integral of du over u will be 1/6 ln of absolute value of u, which in this case, all we do is do back substitution for this. 1/6 ln of 2x cubed plus 1 plus c. Alright. And that's it for this video and for this brief section. Alright, see you on the next video.